All right. So last class we have started number 3, and we talk about the definition of divisor or multiple of something. We introduce these notations, divides notation. Then we talk about some of the theorems. And I have promised you that I'm going to prove one or two theorems. So which one I need to prove? Tell me which one I'm going to prove. Anyone? Any number? I don't think I need to prove all these theorems. One or two prove is enough. Which one I need to prove? Yes.
Sir, I have a question, sir. Sir, আমাদের finals syllabus ki chapter 5, 6 or anything after that? Sir,
Chapter 5 and 6. What is chapter 5 and 6?
induction or counting, sir.
Why? Why are you thinking that syllabus would be induction and counting?
No, I'm asking, is that
Then
a part of the syllabus as well?
then why I'm covering this number 3 and other stuffs?
Uh,
Good. So how
no,
about this? Let's try to prove number 4. Everything is included. So let's try to prove number 4. So what is number 4? Number 4 is like this. So let's try this. Number 4. So this. If A divides any 2 of x comma y comma g, and then it also divides other integer where let's try to put this. কিভাবে করা যায়? Assume without loss penalty that A divides y, A divides g. then it is sufficient to prove a diverse X. Now, a diverse Y. It means what? Y equal to an for sum n belongs to G. A diverse to Z, which means Z equal to an for sum n belongs to Z. Then what is X? X is nothing but Y plus Z, which is nothing but an plus am, which is nothing but an plus m. An plus m. Okay. It means what? It means which implies a device is GMT. We are done with this. Did you get the point? Guys, any query? No query? Okay. If I understand all the theorems, let's try to prove this. If for some particular value 17 divides 2a plus 3b, prove that for those particular value 17 also divides 9a plus 5. How can you prove this? Any idea, guys? If for some particular value 17 divides 2i plus 3b, prove that for those particular values 17 also divides 9a plus 5. How can you prove this? Yes? Any idea? Say something, otherwise I cannot understand whether you are understanding or not. Say something. Guys, have you listened?
Yes, sir, we are listening.
Okay, so let's try to prove. So 17 divides twice a plus 3b. So let's take this thing. 17 divides twice a plus 3b. Can you give me some value for which 17 divides twice a plus 3b? Huh? How about this? A equal to 4 and b equal to 3. Then what is the value of twice a plus 3b? It is nothing but 8 plus 9, which is 17. So 17 divides 17. Now for this particular value, what is the value of 9a plus 5? It is nothing but equal to 36 plus 50, which is nothing but what? 51 and 17 divided 51. So it seems correct. So how can you prove this? See, 17 divides twice a plus 3. Then definitely 17 divides minus 4 twice a plus 3. According to which one? According to definition. Because 17 divides this, so definitely if you multiply this number with some other numbers, integers, definitely that is also divided by 17. Good. Then what? Now 17 also divides 17. So definitely 17 divides 17 a plus b. তাহলে 17 must divides 17 a plus b plus minus 4 twice a plus 3. Now if you, what do you get? It is nothing but 17a plus 17b minus 8a minus 12b, which is nothing but 9a plus 5b. So, which is plus 17 divides 9a plus 5b. Alright, done. Any query, guys? Any query? No query. Now, I'm going to discuss a very important algorithm. Very important algorithm. Okay. It's called the division algorithm. So what is division algorithm? Assume a comma b belongs to G and B
স্যার ক্যামেরাটা একটু লেফটে নিয়ে যায়।
ক্যামেরা লেফটে নিয়ে যাবো মানে
স্যার উপরের অংশ কেটে আসছে এর জন্য আর কি বলা হলো।
ইয়েস স্যার,
এবার
টপ লেফটে দেখা যাচ্ছে না।
জি
টপ
স্যার।
লেফটে দ্য ডিভিশন অ্যালগরিদম, এটা পড়া যায় না?
না
না
স্যার,
স্যার,
এটা
পড়া
কেটে
যাচ্ছে না
আসছে।
পুরোটা।
শুধু অ্যালগরিদম পড়ে আছে।
জি স্যার,
রাইট
এবার
নাও
ঠিক আছে। এবার ঠিক আছে।
assume a comma b belongs to Z and B greater than 0, then A equal to BQ plus R, where 0 greater than R. So this is called a division algorithm. That means any number in Z can be represented like this: PQ plus R. Okay. A equal to B cube plus R. So how can you prove this? How can you prove this? If, say, B divides A, then what? Then A equal to Bn, PQ, where Q belongs to some G. So R equal to 0. Number one case. So it is fine. Number two, we assume B not divide A. We assume B not divide A. Okay. Let's talk about a set S is equal to A minus TV equal A minus TV such that A minus TV greater than 0 and A minus TV belongs to Z. So what can you do? If A greater than 0 and T equal to 0, A minus TV is equal to A minus T into 0, which is nothing but A. It means greater than 0. Means A belongs to S and S not equal to 5. On the other hand, if A smaller equal to 0 and T equal to A minus 1, then A minus TV is equal to A minus 1 B A AB plus B A 1 minus B plus B. Now A smaller equal to 0 and as B greater equal to 1, 1 minus B smaller equal to 0. So again A minus TV greater than 0. So hence S not equal to 5. Now S is a set in Z plus and S not equal to 5 by well ordering principle, there is a minimum value for which S is true. Assume the minimum value is R. So R equal to A minus QV. And then T equal to Q. So R equal to A minus QV. Okay. Now, if R equal to 0, then 0 equal to A minus QV or A equal to QV, which means which means what? P divides A, which contradict our previous assumption. So let R equal to B plus C means R greater than B. Then B plus C is equal to A minus QB or C equal to A minus Q Q minus 1 B. Okay. It means it means it means what? It means R is not the smallest value for which S not equal to 5. So what is the conclusion? The conclusion is R should be smaller than B. So by case 1 and 2, by case 1 and 2, 0 greater or equal to R smaller than B. So we are done. Proved. Now let's go further. Assume A comma B belongs to Z and B greater than 0, then A could be is unique. We are trying to prove this one is unique. So how can we prove this one is unique? We'll go much further. How can you do that? How can you do that? We can do this. See. Assume my negation problem. Assume R and Q are not unique. Let's assume there are two solutions, R1, Q1 and R2, Q2. So okay, so definitely BQ1 plus R1 is equal to BQ2 plus R2. It means B Q1 minus Q2 is equal to R2 minus R1. Or we can write okay. So what is the meaning of this? It means B reverse R1 minus R2. But 0 greater than R1 smaller than B and 0 greater than R2 smaller than B. Then definitely 0 greater or equal to R1 to smaller than B, which is impossible. So the solution is AB. Okay. Did you get the proof of this theorem, guys? Did you get the proof of this theorem? Eh? Okay. Should we go further? We are not going to talk.
Yes, sir, we could go, sir.
We can go further. Okay. So let's talk about this form. So any number A, comma B belongs to Z and B greater than 0 can be represented this way. A equal to BQ plus 1. Here 0 greater than R smaller than B. Okay. And Q comma R belongs to Z as well. Now Q is called quotient. And R is called remainder. Q is called quotient and R is called remainder. Okay, guys, any query? For example, let's take this example. Let's assume our A is 26, B is 3. So how can I write this? So A equal to BQ plus R. So we can write 26 is nothing but 3 star 8 plus 2 তাহলে আমার এখানে q কত what is the value of q and what is the value of r what is q
Q8
r হচ্ছে 2
to
right and এবং 2 হচ্ছে গিয়ে 0 greater than 2 smaller than 3 so it is correct I have already given you that all right guys আচ্ছা
জি স্যার
এবার এই জিনিসটা কি this expression I am going to go further we are going to go further we are going to express this expression in another way that is called modular algebra so when a equal to bq plus r it can also represent it like this way a r mod b did you get it a equivalent to r mod b so here r is nothing but remainder b is nothing but quotient okay r is nothing but remainder and b is nothing but quotient so how can I write this 26 is nothing but 2 mod 2 mod 3 so even further when we are dealing with only quotient of 3 let's say 26 is equal to 2 mod 3 then 30 is 0 mod 3 31 is 1 mod 3 so when this thing is same we even drop this we write like this 26 is nothing but 2 30 is nothing but 0 31 is nothing but 1 did you get the point all right guys
Sir,
yes
sir, I had a query about the exam.
what is query about the exam
Sir, syllabusটা কি স্যার আমাদের যেটা লাইক মানে কুইজটা হচ্ছে ওটার সাথে মিলায় আর
এই
এখন
প্রশ্নটা এই প্রশ্নটা before starting the class someone already asked me why you are asking again
স্যার বুঝতে পারি নাই
স্যার
বুঝতে
আর একবার
পারেননি
বলতে পারবেন আমি একটু লেটে জয়েন করেছি 9:45 এর দিকে
সিলেবাস পিয়াজাতে পোস্ট করা হবে তখন বুঝতে পারবেন
ওকে ওকে
সিলেবাস কি
ওকে স্যার
ঠিক আছে এখন
আচ্ছা
সিলেবাস নিয়ে কথা বল
আরেকটা জিনিস
হ্যাঁ
ওকে স্যার থ্যাংক ইউ
স্যার
স্যার
আপনি একটা মেইল করেছিলেন যে স্যার এই যে ফ্যাকাল্টি এভ্যালুয়েশন আমাদের এক্সামের ব্যাপারে আহ, লিখতে যে লাইক হাউ উই ওয়ান্ট দি ফাইনাল টু বি বা সামথিং লাইক দ্যাট
হাউ ইউ ওয়ান্ট টু
স্যার আপনি
আই ডোন্ট
হয়তো
গেট ইউ
স্যার আপনি হয়তো বা লাইক জিমেইলে একটা মানে আমাদের আইইউবি মেইলে একটা মেইল দিয়েছিলেন হয়তো বা যেটা
জি জি
লাইক ফ্যাকাল্টি এভ্যালুয়েশনের ব্যাপারে
হ্যাঁ সেখানে
স্যার
কি লিখেছি
স্যার ওটা হচ্ছে লাইক ওটা না আমি হচ্ছে বুঝিনি ক্যান ইউ জাস্ট এক্সপ্লেইন দ্যাট থিং কারণ কি আমার
বলছি আমি যে এক্সাম টুলের পরীক্ষাটা নিয়েছি কুইজে
জি
সেই
জি জি
ব্যাপারে যদি আপনার কোনো সাজেশন থাকে রাখতে পারেন
ও আচ্ছা 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 ওকে
মানে আপনি যদি মনে করেন যে টুলটা ভালো ছিল এটা লিখতে পারেন বা
ও আচ্ছা
আপনার কোনো যদি সাজেশন থাকে যে এটা করা উচিত ছিল সেটা লিখতে পারেন
ওকে ওকে
ওকে স্যার
ওকে
আচ্ছা so so when quotient is same we can even write it further this way so some theorem about modular algebra Number 1. A modular equivalent to B logically implies B modular algebra to A. Number 2. A modular algebra B and B modular algebra C logical equivalent C. 3. In number. A modular algebra B and A dash modular algebra B dash. Then number 4.
স্যার লাস্ট অংশটুকু লিখতে পারিনি এক লাইন। স্যার হয়ে গেছে।
So this is the case. I want to prove one. Which one I'm going to prove? Which one you want me to prove? Which one you want me to prove? একটা বলেন, নাম্বার বলেন, র্যান্ডমলি একটা বলেন, 1 থেকে 5 এর মধ্যে।
Sir, 4.
4. 4. A1 modular equivalent B1, which is nothing but A1 equal to A1 equal to, let's say, T1 Q1 plus B1. Then A2 might be written T2 Q2 plus B2. A3 is equal to T3 Q3 plus B3. Dot 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 AN is equal to TN, QN, DN. So if you multiply this with K, A1 is equal to K1 KB1. LA2 is equal to L T2 Q2 plus L P2. এভাবে যাবে লাস্টেরটা হচ্ছে TAN is equal to TTN QN plus TBN. If you add all those, what do you get? KA1 plus LA2 dot TAN is equal to, if you take common, oh, I made a mistake. So it should be Q. So the same question. You can say Q K P1 plus L P2 dot TTN plus K B1 plus L B2 dot TTN. So which means nothing but, which implies K1 LA2 dot TTN equivalent to K B1 L. Done. Proved. Okay. Any query? Now I'm going to do a problem which always comes in the exam. Should I do that problem? It is coming for continuous 3-4 semester.
Yes, sir.
Should I do the math?
Yes, sir.
Okay, sir.
Yes, sir. Please, sir.
স্যার ফাইনালসে আমাদের পেপার কি আপনি বানাবেন নাকি স্যার মিলে বানানো হবে?
হ্যাঁ,
স্যার পেপার কি কমন পেপার হবে নাকি স্যার আমাদের পেপার আপনিই বানাবেন?
ফাইনাল নিয়ে একটা কথা বলতেছেন না, চুপ থাকেন, ঠিক সাইলেন্ট। কমন পেপার হবে না কি হবে তা আপনাদের লাভটা কি? What you are going to do by knowing this?
না স্যার, ফর ইন জেনারেল জানতে চাচ্ছেন।
ইন জেনারেল এটা কোনো জানার বিষয় হলো? এক্সাম দিয়ে করবেন কি আপনারা? কমন এক্সাম হলেও কি আর সেপারেট এক্সাম হলেও কি, মানে লাভ কি আপনাদের? যেটা হলে করলে লাভ সেটা করেন। এক্সাম্পল,
স্যার আপনি বানালে স্যার আপনাকে একটু বলতাম পেপারটা ইজি করতে।
what is the last digit of 7 to the power 9999? What is the last digit of 7 to the power 9999? How can you find? Yes. Tell me. How can you find the last digit of 7 to the power 9999? Any idea, guys? What you are going to do? You are going to multiply 7 9,999 times. Do you know how big that number is? Huh? What you are going to do? So if you try to multiply 7 up to 9,999 times, then it will be a mess. You can never get the answer. So what you are going to do? You are going to use modular algebra. See, 7 to the power 0 is equal to what? 7 to the power 0 equal to what?
1.
Good. 7 to the power 1 equal to what? 7. 7 square equal to what?
49.
So multiply this 7 with another 7. So 49. 7 cube equal to what? Forget about this digit because I want to find the last digit. So something dot 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 63. Okay. Now 7 to the power 4 equal to what? 7 to the power 4 equal to what? 7 to the power 4 equal to what? Something, this 3 multiply with 7. So 27. Now see, this 7 is written here. Did you get it? 1, 7, 50, 63, sorry, 21. This 1 is written here. Okay? Now what happened? So after each 4 round, 1, 2, 3, 4, we are getting back the last digit. Same last digit. Do you agree with me or not? After each round, 1, 2, 3, 4, we get back again. Then again, 7 to the power 5 would be j. As it is 1, the last digit would be 7. Then 7 to the power 6, last digit would be 9. So this way it will continue. So we can say this is nothing but 4 into 0 plus 0, which is nothing but 0. 4 into 0 plus 1, which is nothing but 1. 4 into 0 plus 2, which is nothing but 2. 4 into 0 plus 3, which is nothing but 3. Again, this one is nothing but 4 into 1 plus 0, which is nothing but 4. So because we can number this way, 0, 1, 2, 3, 4, so on. Okay? Now, how can I represent 9999? 9999 is nothing but, if we divide 999999 using 4, what do we get? 8, 19, 16, 39, 39, 3. So 9999 is nothing but, am I right or not? Yes, I'm right.
Yes, sir, you are.
I'm right. So 9999 is nothing but 4 into 2499 plus 3. So that means whatever the last digit, sorry, so whatever the last digit for remainder 3, that would be the last digit. So what is the last digit for the remainder 3? 3. So last digit would be 3. Did you get the point?
Yes, sir.
Okay. So this way you can find anything. So this is a very important example, and hopefully this semester it would also come a problem like this. যদি লাস্ট 2 ডিজিট বলে সেক্ষেত্রে কি করবে? What you are going to do? If it says last 2 digit, what you are going to do? Last 2 digit. Then what you are going to do? So instead of taking care of 1 digit here, you are going to take 2 digits. Okay. All right. What else? Let's talk about prime numbers. So what is prime number? What is prime number? What is prime number, guys?
A number that can be divided by itself and one only.
Prime number? Any number which is divisible by only one and that number. But there is a catch. One is not prime number. Though one fulfills its criteria for historical reason, one is not considered prime number. Okay. Now what is the first prime number? What is the first prime number?
2.
2. Then prime numbers. So what is the first prime number? 2. Then 3. Then 5. 7. Dot, dot, dot. Okay. And numbers which are not prime are called composite number. So what are the composite numbers? One, 4, 6, 8, 9, so on. Okay. Okay. All right. So let's try to prove this theorem. Any composite number is divisible by a prime group. How can you prove this? How can you prove this? How can you prove this? Any idea? So we are going to prove by negation. Assume this is not true. So by well ordering principle, there is a list number m which is not represented, which is not divisible by any prime number. So m equal to m1, m2. Again, m1 cannot be prime. So m1 is a composite number. Again, not divisible by a prime. So contradiction. Because then, but m1 smaller than m. So contradiction. So we have done. Good. Okay. Guys, how about this? Number of primes are infinite. How can I prove this? Number of primes are infinite. How can I prove this? Assume number of primes are finite and the last prime is P. So now M equal to 2 star, 3 star, 5 star, dot, 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 P plus 1. How about this number? M is not divisible by any number 2, 3, 5, dot, dot, P, then either either M is a prime or it is divisible by some prime greater than P. Both cases, theorem 2. Yeah, UAD. Okay? আচ্ছা এবার লাস্ট টপিকটা টুডে Euclid's GCD algorithm. What is GCD? What is GCD algorithm? What is GCD? What is GCD? GCD is nothing but divisor. GCD, greatest common divisor. So the greatest number, the biggest number which divide both of two numbers are called GCD. For example, let's take 12 and 8. So what is the GCD of 12 and 8? What is the GCD of 12 and 8? What is the biggest number divide both? Yes, no? So simple. 4 divides 12 and 4 divides 8. And hopefully this is the biggest number. So GCD 12, 8 is nothing but 4. So there's the algorithm to find this number. And that is nothing but called GCD algorithm. So what is GCD algorithm? It will be like this. So how can you find the greatest common divisor? Like this one. So 12, 8, 8 equal to 8, 4. Then next time make this one as divisor. At first take smallest number as divisor and biggest number as dividend. Then you get some remainder. Then new remainder. This new remainder will become new divisor, and previous divisor will become dividend. Now 8, now 0. Now when you get remainder 0, 0 equal to 0, terminate the algorithm, and the last divisor is equal to GCD of original numbers. Okay, so at the last we get divisor equal to 4. That time remainder is 0. So GCD of original number 12,8 is nothing but 4. Okay, so let's write this algorithm this way. What is the algorithm? The algorithm is like this. Euclid's GCD algorithm. It is like this. So let's say we want to find out GCD of A comma B. So A equal to something like this: BQ plus BQ1 plus R1. Where then B equal to R1 Q2 plus R2. Then R1 equal to R2 Q3 plus R3. This will continue. At the end step, Rn is equal to Rn minus 1 is equal to, let's say, n minus 2 is equal to, let's say, Rn minus 1. That time we terminate. So GCD of A comma B is nothing but the last divisor, which is nothing but Rn minus. So this is the algorithm. Did you get it? Any question? Any question, guys? Last divisor is the last divisor for remainders. That is the gist. All right, guys. Should we stop here today?
স্যার
Huh?
হ্যালো
Yes.
আপনার সাথে একটু কথা ছিল আমার, আমি
Yes.
সবাই যাওয়ার পরে
Tell me.
বলতেছি।
সবাই
একটু
যাওয়ার পর
wait
বলো
করবেন?
কি কত কি? তাহলে মেল করেন। সবাই যাওয়ার পর এখানে গুগল ক্লাসরুমে কথা বলাটা ঠিক হবে না। মেল করেন, মেলের জবাব দেন। ঠিক আছে?
ওকে
Just take the attendance. শুনেন একটা কথা বলি, এই at the very beginnings course এটা ফাঁকি দিয়ে করে লাভ নাই, এটা ফাঁকি দিয়ে করে নিজেই পস্তাবে। সো বি কেয়ারফুল। ওকে, ডিসক্রিট ম্যাথমেটিক্স ফাঁকি ঝুঁকি দিয়ে পাশ করে গেলাম, ভাববেন যে না পার পেয়ে গেছি, না পার পাবেন না, প্রতি পদে পদে ঠকতে থাকবেন। So it is better to be very attentive in this class. Okay, all right.
Yes, sir.
So should we leave?